To my YouTube channel. So today we're going to make a password-based door locking system as you see here on Tinker Card and Arduino. So as you see, these are LCD display, these are Arduino board, this is a keypad, these are servo motor, a potentiometer to control the contrast of the LCD, and the LED here that on red if your password is correct, that on green if your password is correct, and red if your password is wrong. So let's try. The password is 0123. So 0123. Access granted, welcome. We have this green LED on and our server motor rotate to show that the door is unlocked. So we have to get in within 5 seconds and the door will lock again. 2, 1, locking, then locked. The door is locked. So the servo motor rotates back to its original position and our LED is off again. So if I press on a wrong password, let's try a wrong password 0115. Code incorrect and you're on the red RGB. In creating the circuits, we'll need a Arduino board as you see here, and also we are going to need a servo motor and a breadboard. So I'm just picking all the elements now. Then we are going to need LED. I'm going to need the LED. Then anytime you're using an LED, we also have to use a resistor. So I'm going to need a resistor, and most importantly, we are going to need a keypad. So it's not here, so you have to search it. Keypad. So, oh, my spelling is wrong. Keypad, so this is it here. So we also need a keypad. So now let us arrange our circuits very well. So you can decide to rotate. This. So something like this. Then let's bring here something like this, or let's bring our keypad here. Yeah, something like this. Oh, skip. Let's bring this to somewhere here. Yeah, and our servo motor somewhere here. So okay, so let us arrange our components that we have here. So I'm going to bring my breadboard from here to somewhere here. Now my Arduino here, my keypad to be somewhere here. Now my servo motor, I like to rotate it to something like this, so for easy connection. So there's no easy way, there's no one way of connecting it. You can connect it anyhow you like. But we trying to move this to somewhere here. Now our breadboard can be somewhere here. Yeah, so there's also one component that we need, an LCD display. So I'm going to be using this LCD. I'll bring it to be somewhere. I'll put it somewhere here too. So I think that's all we need. So first, let us connect our keypad. Now on this keypad, we have, this is a 4x4 keypad. That means 4 row and 4 column. So these are first row, row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4. So row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4. So we are going to connect our row 1 to the dictator pin 0, row 2 to dictator pin 1, and so on. So let's start our connection. So row 1, so we are going to connect it to pin 0. It's connected. We can straighten this. Yeah, and change. Then row 2. for this ABCD because the our keypad, the password to our key is 0123. You are going to see it in the code very soon. So I don't really need to connect the alphabet part of this keypad. So now let's just try to make this wire look good because we can change the color and make it straighten each one of them. Yeah. Let's bring it closer. Okay. So let us change the color. So let's bring it. I like making the color from red and black. I don't want to use it because this red will symbolize my terminal, and this like my positive terminal and my negative terminal. So I would like to start changing the color from orange. Then the second one can be yellow, the third one green, the fourth one let's use this color here, and the fifth one, it doesn't really matter, just to like beautify our circuit. So I'll make this purple, then this pink. So now we've connected our keypad. So let us connect our servo motor. Now in our servo motor, we have the first part, this is the signal. We have to connect this signal to the digital pin 9 on Arduino board. So let's connect that. So let me bring it closer a little bit. And then now it's connected like that. Then now we have power and ground. So to do this, let's connect our power and ground to our breadboard. So I'm going to connect my 5 volts to this positive terminal. If you are used to breadboard, you know that we can connect like this. So power, let us change it to red. Now our GND, which is ground, I can connect it. Let me stop it here and connect it to this ground. Now let's change the color to black and straighten this. So now we know that on a breadboard, this power side on the breadboard, they are connected horizontally. So every part of this piece, they are connected like this. So now we can just bring our power from here to this place. We can connect it this way, or yeah, we can connect it this way. Now for our power, connect it like this. Yeah. Now let's change this to red to know that it's power, and we can connect our ground to this place. Which is black, and let us arrange this well. So now our servo motor has been connected, but I want us to not connect it like this because I want to extend this power to this upper side of the breadboard. So I don't want to connect this. So let me remove this and just bring a jumper wire like this and jump it here. So red and the black for the negative. Yeah. Now, so we've connected this like this. So now to connect this servo motor, we can just extend this power line to this place, and let me change to red, and I'll extend this power, this negative, to this place, and let me change it to black. me change this to black and this to red. So now what I've done is that I'm extending this power with a jumper wire. So now we know that this part of the breadboard, these two parts of the breadboard, they are connected vertically. So when I connect this to this, so I've connected power, the 5 volts to this part. Now let's connect our LED. So now I'm using a, you can see it, I'm using a LED, one single LED, but that can on blue, green, and red. So blue, green, and red. So I will know on our LED, I'm using like a one LED that can on different light, 3 different lights. So these cathode parts, these are ground parts, like the ground, and these other 3, this like the anode parts. So this is green, this is red, this is blue, and this is red. So what we just need is red and green. So when you enter a correct password, it will on green. When you enter a wrong password, it will on red. So I also need one more resistor. So what are we going to do? This is our cathode, Abby. So we can just connect it to the ground like this. Cathode has been connected to the ground. Now for these 2 resistor, we have to connect this is green, right, to digital pin 12, and the red to digital pin 13. So let us do that now. So 12, I can just go like this. Yes, I can go like this. And remember that since I've jumped, like look at the way I inserted the resistor. Here is a bridge. There's no connection between here and here. So by placing my resistor here, I've connected a connection. I've like created a path for current. So I remember that this part are connected vertically. So I can just put it anywhere here and they are still connected. So let me make it straight and change the color. I don't need to use red or black. Let's use brown. Now for digital pin 13, that's our red. So I'm going to connect it to somewhere here. So let me change the color to gray. So let us look at it. Okay. Think it's straight, right? So we have connected our LED now. So next is to connect our, what's it called, our LCD for the digital display that we are using. This is like LCD 16. Let me show you. This part, this LCD 16 times 2. So now look at it. We have on this LCD, we have ground, we have power, which is VCC, we have contrast, and we have some other pins that we are going to connect. So to connect it to our Arduino board, so since I've used most part of this digital part of my Arduino board, so I can connect my LCD to this analog parts. So it's not necessarily, it's not like it's compulsory. You can connect it to the digital or the analog, but here I want to connect to the analog. So I want to start from the D7. So from here, connect it. I'll connect it to the AO. That is here. So straighten this down. to A4, A5. So my RS is going to be connected to A5. So let's go. My if RS, sorry, what am I saying? My RS, this read or write, register select is going to be connected to A4, A4 right here, and my enable is going to be connected to A5. Although the order doesn't matter, but the reason why this order matters because of the code. So in the code, that's how it's connected. That's how I wrote it in the code. So I have to connect it in alignment with the connection. The code must be in alignment with the connection so that it can work. So RS is going to be connected to what? A4. So let's connect it. A4. So something like this. Let's straighten this. Bring this closer a little bit. Yeah, so that's what we want. Then our enable is going to be connected to A5. So I'm going to connect it like this and like this. Then this RW, this read or write is going to be connected to the ground. Yeah. So now before we connect that, let us change the color code of this. So this is already green. Let's change this to another color to make it beautiful. Let's change this to another colors as well. Blue, purple. Can use orange here and gray. I think it's okay like that. So we've connected this. Now we need to connect our read or write to the ground, this to our 5 volts power, and this to the ground. So let me first connect my VCC to the power so I can bring this a little bit down. Yes. So let's connect our power, and we know we have extended our power to this side before, so we can just connect like this. And you know our power, we always use red color. So then the ground can be connected here. This is our ground. And then, so this read or write, where is it? Read or write is also connected to the ground. So I can connect it here. And don't forget that this power, this in these two sections, this power section of the breadboard, they are connected what? Horizontally. See, if I over on one, it shows that what the connection is connected like that. So I can just connect the power, my ground, anywhere on this line here. So let's make this straight. Yeah. So now, if we start simulation, you see the LED is just blinking to show that there's a connection, but it's not really on it. And our LCD too has not yet on. So let me stop simulation. So the next thing that we need to connect to our LCD is this this LED, this LED. So the anode is going to be connected to 5 volts, and this cathode is going to be connected to the ground. So let's do that now. In this LED, so the anode, this is a LED. So it's going to be connected to our power. It can be the 5 volts. But don't forget that when you're connecting a LED, we have to use a resistor, so that to control the flow of current. So you know a resistor oppose the flow of current so that it will not burn our LED. So I'm going to pick another resistor. I'm going to put it somewhere Yeah. Now note on the resistor, if you hover here, this terminal 2 and this terminal 1, right? This terminal 2 and what's terminal 1. So we can do it something like this. So we are going to connect this part to our LED, the anode part of our LED, to something like this. You are going to connect it to terminal 2. Then you are going to connect the terminal 1, that is the power, to the 5 volts, to the power down here. So if I start simulation and we have connected our cathode, this cathode, you connect it to the ground also. So you connect this cathode, you see that it's connected to the ground here. So when we start our simulation, at least our LCD show on. So you see that it's on, but it has not displayed anything because there's nothing in the code yet. So now let's do our color code, straighten this. Now for this is red and this is black. I'm sorry, that was it. So now the next thing that we need to connect is our potentiometer. So to control the contrast of our LCD. Connect our potentiometer, you pick a potentiometer here, you can place it somewhere here. So on the potentiometer, we have terminal 1, we have the middle part, which is the Y part, and it's the second part, which is terminal 2. So first, connect terminal 1 to the power, 5 volts. Now, terminal 2 to the ground. Connect it to the ground here. So change the color to black. Now, this middle part is going to be connected to this VD, contrast of our LCD. So we can just go like this and let's say bring it down here. Then I can put it here. Sorry, I'll put it here. Yeah. So we can change the color, this we can put it yellow. So now we have connected our contrasts. So this is our circuit. We are done with the circuit. So let me change this color. I don't like this yellow, it's too bright. Let me put something like brown. Exactly. So now note that when you are using this type of LCD, you will always need to connect this potentiometer simulation. So you see, if I reduce this potentiometer, the contrast, you see this is the contrast that's reduced. When I increase it, the contrast has increased. So the next thing that we need to add is, let me stop my simulation, is our buzzer. So if you check here, I've already searched it here, you can just search a buzzer. So pick the buzzer, put it here. Now the positive side of the buzzer is going to be connected to the digital pin here. So let me see, I'm sorry, let me drag this buzzer well. So you connect the positive side to the digital pin 10. So it's connected. You can straighten it like this, and this to the ground. So the negative side, you connect it to the ground. Yeah. So let's change this to black. So all our connection has been connected. So the next thing is for our code. So the code, I've copied the code because if I want to write the code, it's going to take a lot of time. So I've written the code and I've copied it. So I'll just paste it here. So this is the code here. This is the code right here. So if you want the code, you can check the link in the description below. So this is the code. These are liquid crystal for our LCD. These are servo motor. For the servo motor, this is the keypad. Now let me remove this. So this is the keypad. And also, yeah, this is the code. So maybe I'll make a video to explain the code better. But this is what I want to show you. The character password for this code is what? 0123. So if you change it to anything you want, so that's the password. But let me put it 0123. And also note that in the code, in the sequence of the code, we use a for loop right here. So what this is doing is that if the key press, if it is correct, you'll be allowed to enter the next key. But if the first key pressed is wrong, you will not be allowed. You see S incorrect, and you to change your current position. So you'll not be allowed to enter. So the sequence, you have to press the correct key in the right sequence. And also, so this is a function for unlock door. We call the function up there in this loop before. Maybe unlock door. Let me show you. See this unlock door that we call here. So this is the function here. So we have void incorrect for the incorrect password and the counter beep. So after you have entered the what's it called? There will be a beep, a countdown of 5 seconds. So if you do not enter within that 5 seconds, the door will automatically lock. So let me change this to 1000. The delay. We are getting within 1005. That is 1 second. Yeah. Okay. So this is the code right here. So that's all. Let us start simulation and see what we've done. So the reason why we are not seeing increase the contrast of this, yeah, enter the code to unlock door. Please put the contrast, the potentiometer, put it to the maximum. So enter the code to unlock door. So the code is what? 0123 0123. Most of that buzzer is too much. I don't really think it's necessary here. So let's just remove the buzzer. Let's remove the buzzer and we'll start simulation again. So now I want to show you some things. So enter code 0123. So after you've entered the code, you see access granted, welcome. This LCD on the green lights and the servo motor rotated to show that what the door has been unlocked. So you have to get in within what 5 seconds and the door will relock. This is the countdown beep. So getting within, relocking, and it's locked. So the LCD is off back and our servo motor rotated also. So now what if I press the wrong password? Let's say I press 0, 0, 4, 5. You see code incorrect, and I have what the LED on was red. So thank you for watching. That will be all.